Alright, so this is just a very quick little demo. I've got some colored water over in this side, and this side's clear. What I'm going to do is I'm going to start this. Like this. A little bit of a kink in there. It's not going to bother us too much, I don't think. You notice what's happening is the liquid is moving from one side to the other. Now eventually, you'll notice now the two sides are the same, right? So what's going to happen if I lift up this side that my hand's on? Like if I do this, can you predict? Right? If I go like this, what is happening to the liquid levels? Now I'm going to put it back down. I'll do it one more time. I'm going to lift this side up now. It's not a trick. Put that back down like that. I may have messed it up by breaking the siphon. Yeah, I think I did. I thought I heard the air go in. Let me get it started again. There we go. All right. And what happened? Well, they're back at the same level. And so regardless of which way I lift this thing up, what the liquid actually is trying to do is maintain a level. And we call that an equilibrium. It's trying to maintain an equilibrium between the tops of the liquid. We'll talk about that in our lecture. So our topic today is actually chemical kinetics and equilibrium. And so let me give you some real quick definitions. I'll talk about kinetics, and then we'll talk a little bit, actually the rest of the chapter, on equilibrium. So kinetics is how fast a reaction goes. So if you remember when I stuck the straw in and started siphoning, how fast it was going, right? And it actually slows down as it gets closer and closer to equilibrium. This is actually sort of a general feature of chemical reactions that we see in lots and lots of chemical reactions. Initially, reactions are very fast, and then over time they slow down. So we'll have to think about like why that actually happens. So we have kinetics on how fast, and then we have an equilibrium, which we would say is how far. Like how much, when we say how far, we would be thinking about like how much product would we get out of a chemical reaction. And so we'll talk about those things in our lecture today. So let's begin by talking about kinetics. So the first thing that comes up in kinetics is reaction rate. Reaction rate, if you think about what that means, is how fast a reaction's going. So when you're driving, you have a rate too. You have miles per hour. So a rate is usually given as a quantity over a unit of time, okay? And there are many things that affect reaction rate, and I'd like you to know what these things are and be able to predict, like if I make changes, what these changes will have and how the changes will affect the reaction rate and ultimately how fast this reaction is going. So the first part is we have to think about something called collision theory. And there are basically 3 or 4 parts to it that you kind of some of it's lumped together, but it's 3 or 4 parts of it you have to think about. In collision theory, it basically says if I have 2 molecules, and let's say A plus B gives me C, like that. Well, in order for this reaction to happen, collision theory says they just have to run into each other, right? So collision frequency is often one of the things that we think about in collision theory, how fast things will collide. So the other thing, though, we have to think about is molecules when they're formed. For example, let's say I have O2 like this, and then I have CO like this is carbon monoxide, and then I make this bond like this. And that comes out of it, and might get 2 of these, let's say, for every one of these, for example. Well, in order for that to happen, the oxygen has to run into the carbon. So there has to be an orientation between the molecules as they collide. And the third aspect is that they have to have enough energy so that when they collide, that the bonds can rearrange. Because you remember what Dalton said about chemical reactions. Chemical reactions are really just a rearrangement of the bonds in the molecules that are the reactants to form the products. So a rearrangement of bonds needs to take place. The molecules will have to be properly oriented, and there has to be enough energy. The activation energy is what we call it, has to be high enough. You have to have enough energy to exceed the activation energy. And really, most of what that energy is, this is to break bonds. So these are sort of basically the premises of collision theory. Molecules have to collide to react. So there's a frequency component to this as well. Then they have to be properly oriented, so that's the shape of the molecules. And then they just have to run into each other with enough energy that bonds break, and the bonds can then rearrange once you've broken some of the bonds.